Okay, welcome. It's a big room. I'm glad that some of you are interested in Azure machine learning and data science. I'm very happy to see those of you who decided to come here rather than enjoy talking outside next to the coffee and extra bread. Well, I promise that the next 57 minutes or so will be quite fast-paced and hopefully will give you a good overview onto the title subject of this presentation. But before I do so, a quick introduction to those of you who haven't met me. My name is Rafal Lukawiecki. I don't work for Microsoft, never worked for Microsoft, but I've worked with Microsoft for now 25 years. And in the last 10 of those 25 years, I had the pleasure of specializing in data mining. But this session is not about data mining, but don't worry, because it's pretty much the same thing. It's just that data mining was a name that some people decided wasn't marketable enough, so it got changed into machine learning. Data science is actually different from data mining. Those are different subjects, but they are part of each other. At the end of this session, if you have any questions, I will try to answer some of them off stage, so I'll get off stage as quickly as I can so that the next presenter, Brent, can set up over here. And that would be really the good session to stay for. So you might just as well stay in this room because the next session will be pretty cool. But I'll take the questions in case you want to ask them slowly walking outside of the room. I also have my email over there and my Twitter hashtag if you want to get answers quicker. Tweet me a question. If you want to learn more, I would like to very briefly highlight your attention at two resources. One is my company's website, projectbotticelli.com, where about 2.5 years ago we started offering online video-based training with the face of the presenter smiling at you and explaining things slowly. Kind of cool how it looks, but hopefully also very relevant to your interests if data science or BI is what you do. There's over 38 hours of material. I cover data mining and data science. Alberto Ferrari and Marco Russo cover data analysis expressions. Chris Webb covers multidimensional expressions and cube building, our newest course. I believe there's also content from a few other authors, including Carmel Gunn and Bob Duffy, primarily focusing on consuming BI using Excel today. But the very first European course in-depth hands-on on Azure ML will not be very far from here in a few weeks on the 25th of May. It's hands-on, so it's only limited to 15 people. I'm not sure how many places are left, but if you are interested, hop on to that website, or if you are interested, hop on to our website to redeem the very special offer that's only valid this week. Until the end of this week, everybody in this room can get a free 1-month membership to all of our training courses. I don't normally give it out. We do it only about twice a year, once here, and the next time we'll do it will be in Chicago. So this code will appear again at the end of the presentation. I kind of have to move on with my slides, but it's actually probably best way if you want to spend some money is to redeem them both. It shouldn't work, but you can use both. Why would you want to do data science? Because it helps you understand why things fail or succeed. Because it helps you understand your customers, your products, and yourself. Because you can build better experiments and ultimately improve your organization. Of those today, the main reason people do data science is the first two. In the next decade, the main reason will be number 3 and 4, as businesses increasingly will be making decisions not only based on intuition of an experienced, probably somewhat older and more mature member of the staff, but also by playing around with ideas. Should we do this or that? Well, let's try in an experiment in which, with a very cool statistical eye, we will decide what is the correct decision to reach. Ultimately, for some organizations, it will enable you to run your business on analytics. Companies like Netflix, companies like Spotify, are companies that own nothing, no hardware, no software, no IP, since everything is in open source. They just own the best analytics on the planet. I'm not suggesting that that's what should happen to all of your businesses, but it certainly will happen to quite a few. Data science, the main subject of this presentation, is an intersection of 4 approaches and something special. Those 4 approaches are good old-fashioned statistics, The badly named big data, I'm not going to talk about it, but it's a bad name. It should be just called complex data. Actually, it shouldn't be even called data, because it's not about the data, but the combination of the data and the problem that makes it big. Because small data with a big question is big data, whilst big data with a small question is not actually big data, but marketing people decided to call it big data, so let them have it. The very mundane but important data wrangling, mangling, what keeps most of you in business. 80% of every project I have done in data science is wasted, erased, spent on you guys trying to get data to a better state, cleansing it, reformulating it, and engineering features out of it. But you know what? Data science is not all of that together just as a technology, because then it wouldn't be science. Well, it could be a marketing science, which is not science, but well, actually maybe it is. No, it probably isn't. It would be called simply data engineering. Why do we call it data science then? Because it has one additional principle, the principle of reasoning, which says that before you make a decision, you formulate a hypothesis of what should happen, and then you test it with data, preferably using an experiment. Do you know what that's called? In the last few hundred years, this has been known as the scientific method of reasoning. And that's what makes data science science, is that we are applying the scientific method of reasoning to decision-making based on doing those things with your or your customers' data. Machine learning, which is of course the subject of this presentation, is not new. It's a fairly old bunch of algorithms and some newer algorithms that find interesting patterns hiding in your data. In theory, it's fully intelligent, throws some data, it tells you what will happen in the future. In reality, it never works like that. It requires to be guided by people maybe like you. If you decide to learn this and follow this a little bit more, you will be probably doing far more manual guidance and tuning and selecting and thinking about what is theoretically machine learning, that we really shouldn't even call it machine learning. It's kind of, you know, it's bad advertising, because it's actually you will be learning, machines will be just giving you some answers. But anyway, I didn't invent the name. Who will do it? A business person who knows the domain of what they want to solve. A data expert, that's probably you, and an analytical expert, that could be you, that is me, that is people who connect those two worlds together. Who knows whether you can connect them together? Until you start a project, we don't. But of course, when it works, those three people, the domain expert, the data expert, and the analytical expert, also known as a data scientist, typically follow this simple process of wanting to change business, finding data that proves or doesn't that this change is possible, and validating it by building a model that connects the two together. For example, let's say you are interested in fraud detection. For some reason, I've been doing a lot of those projects recently. I don't know why. I'd rather do more positive things, but I do others too, but this has been popular recently. Well, the business says we want to reduce fraud. So then the data expert has to show me examples of fraud in data. You need to be able to stick your finger at a row of data and say, this is an example of fraud, and this is good. If you can't do that, if you can't show me that, we can still do a few things, but generally not a lot. Once I've got this data, my next point is to see if I can predict fraud based on the data you've given me. I realize, to those of you who know something about this, that I'm describing an approach known as supervised learning. It is possible to do it in an unsupervised fashion, but for practical purposes, the way I'm describing it is the way it is done today. And very often, I will not find a pattern, or I will. But it will not detect exactly what the business person wanted. The business person will say, you're catching fraud, but this person didn't know what they were doing was wrong, so it's not fraud. Okay. So we change the definition of fraud. We need new examples of data, and I will build, hopefully, a better model, which will find something different. The business person, no. You need to be finding the ones who know what they're doing, no matter how big or small it is. But if they didn't know what they were doing, that was like huge, then we'll call it fraud anyway. Okay. So we're going to change the data and build a new model, and each time it could be different algorithms, different performance. You know what? If you find 17 definitions of fraud on a fraud analytics project, at the beginning you're doing well. Sometimes it goes into low hundreds. Do you know what's best when this happens in a company? That those people, those 3 people, will start working as something that's much bigger than just fraud analytics, than just improving marketing, targeting your processes, predicting failures, improving your customer retention, predicting profits. The best thing is that you will start building this nucleus of organizational intelligence, where between these 3, the domain, data, and analytical expert, cool stuff happens that eventually helps you run your company based on analytics. Don't outsource this part to another company. If you are a customer, keep it in-house as much as you can. O'Reilly did a survey just over a year ago. I have permission to show this. I need to ask them to give me permission to show a fresher version, apologies, of this slide. What tools do data scientists use? And to everybody's surprise, SQL happens to be the #1 tool. Now, that doesn't mean Microsoft SQL Server. It means any SQL structured query language out there. Interestingly, #2 is this new kid on the block, R. Not quite new, it's over a decade old, but it certainly seems to be pushing out the old players who are at the bottom of this list, who created this space, followed by Python and Excel. The last year's survey changes the order a little, and to everybody's surprise, Excel has moved up. Which is kind of funny, because everybody loves to hate Excel, but we use it anyway, and the statistics show it. In my company, when I do analytics, I primarily use the top ones. I also use Mahout library of machine learning algorithms on top of Hadoop, especially for recommendation engines and gap analysis. I avoid using Java as much as I can, and occasionally I try to use data-driven documents, but not very successfully yet. Indeed, my toolkit originally began with SQL Server Analysis Services data mining, which is still one of my most favorite analytical data mining and machine learning tools, and I use it a lot. Followed quickly with Excel, and more recently Power Query, which is really the main reason I like Excel, are using the interface of RStudio primarily for statistics, but also for some mining. And those of you who might not know about it, about 2 weeks ago, Microsoft decided to acquire Revolution Analytics, who are one of the makers of a commercial distribution of R, which solves some of the problems that the free version of R has. SaaS people like to say that R is slow, which is unfortunately often true, and out of memory is the most frequent message you will get when you use R. And those things can be solved using commercial distributions. One of the most popular commercial distributions is Revolution Analytics distribution, known as Revolution OpenR, available for free, but also available for a fee if you work for a company which is not allowed to buy free software for free. You can buy free software and pay some money if you want. That's supported fully. Of course, Mahout and Hadoop, which I use primarily for recommendations, but I am also evaluating 2 frameworks now, Spark and H2O. Haven't used them much really, so don't ask me questions, but started touching it. I am not using as much Python as I probably should, but I like it. And of course, the newest kid on the block is Azure Machine Learning, which I use primarily for data mining, and I will talk about a little bit later. By the way, no difference. Data mining and machine learning is the same thing. It's just that data mining is an old term that some people don't like because it was burned, especially in the United States, but in other English-speaking countries too, so we renamed it machine learning. True? Almost. Actually, there is a difference, but the difference is so small that it doesn't matter. The difference is that machine learning, in theory, does not have to be used on flat tabular data. You could use machine learning to build artificial intelligence using some temporal unstructured data in the memory of a computer. Is that what Azure ML does? No. Is that what Weka and every other tool does? No, 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 no. We all use machine learning to analyze tabular traditional data equals data mining. Between me and you, new name, old name, but follow your marketing people, which one you're allowed to use. As far as the tools and the approach is concerned, I have built my business. Project Botticelli is now 15 years old. About 10 years ago, discovering by mistake in a taxi journey somewhere in Croatia, going to a conference, that there was this thing in SQL Server Analysis Services called data mining, SSAS data mining, that nobody knew about, which was great because all of my customers already paid for it and I had no competitors, except maybe for Dejan and a few other people who knew about it. You know, it was kind of cool. We could go to a customer and knock, knock, you've already paid for it. I'm just going to get you some answers. So that was good business. Now, everybody talks about machine learning, so I actually have to start competing with others, which is kind of tough, but I guess it's good for the business in general. I also use R. I use R both for the easy parts, like descriptive statistics, and the harder parts, like some of the machine learning algorithms, which I cannot find in SSAS, but I find in R. And only after I've done the first two things, I go to Azure ML. Why? Because SSAS is very easy, very visual, intuitive. Excel, it just works. It's also old. Old is good. It's debugged. Right? It doesn't fail you in crazy ways. Well, it fails you a little bit, but you know, click twice in this box and scroll this way and a bug goes away. You kind of know how to work around that. R is descriptive statistics, gives you feel for your data, but it's a little bit geeky, so I make it a little bit easier by using an add-on on top of R called Rafal, which is free. And Azure ML I primarily use because of a few of those advanced algorithms that it has. One of my favorite parts is auto-tuning of parameters that Azure ML does. And of course, the web deployment is the one I will tell you in 1 year from now is the reason I use Azure ML. But right now, since it's only 2 weeks out of the box, I have to tell you that that's the most attractive reason in theory. I think it will be the main reason people will use it. Machine learning, data mining, whatever you call it, explores your data, finds patterns, and predicts. Predicting is also called scoring. Scoring is a machine learning term. Predicting is a data mining term, but it's the same thing. And most people think that predicting and scoring is the most important part of it. No. The most important part of machine learning is exploring your data, visually understanding what happens. When you feel your data and your model, then you may want to do predictions. And when I talk about predictions, people think I will be predicting the future. No, I will be predicting the present and the past and the future. And guess what? Predicting the present works quite well. Predicting the past works quite well. Predicting the future doesn't work so well. Most of my customers want to predict the future, so in the early contract negotiation, we redefine the future as more or less present. Kind of works. Good salespeople help in that too. What's the problem? The problem is that if you predict the future, you are assuming that nothing else will change. But your competitors will start competing, the world may come to an end, and Martians may offer SQL Server for free, right? So everything can change. You cannot predict that. Of course, Leibniz would argue with me that if you had a table in which you put absolutely everything around the world, the whole, put it through Azure ML, it would predict everything, but practically it doesn't work that way yet. So, why predict the past? You want to know what happened. Why did I fail? Why didn't they buy my purple widget? What's happening now? Is this transaction fraudulent? Is this customer happy? Predicting the future, how much will I sell, is cool, but not too far into the future, just a little. Actually, the less into the future, the more it looks like predicting the present. Actually, when I predict whether this transaction is fraudulent, I'm not predicting the present. I'm predicting the present plus maybe a few seconds. Will this transaction defraud me in a few moments? So it's a soft boundary. But generally, you need to have the indifference towards exterior change in order to predict the future, or be careful. Predict the future carefully. How? Define the model, train the model, validate the model. Which is the most important one? I can hear you say, validate the model. Of course, the most boring part is the most important part. Define the model is easy. Attend my yesterday's pre-conference seminar. You'll know how to do it. Train the model is easy. Push a button. Validate the model. define the criteria of validity, of accuracy, of reliability, and of usefulness. If you attended my pre-conference seminar yesterday, and slides are, by the way, on the website, and you can watch the videos on the website with that free coupon, you would have learned about metrics such as precision and recall, and balancing one against the other. Some people call them sensitivity, specificity, slightly different but similar. Or balancing accuracy against the cost of the model. And everybody will have different metrics. But once you know what's important to your business, because your budget is limited and you'll just do as well as you can, or do as well as you can, who cares about the budget, you'll either focus on precision or recall. Precision is connected to your budget. Recall is connected to your performance. Talking to the business person in a language they understand will translate through the data and analytical expertise into a model that not only works, but which is also valid, not just technically, but also for your business. Oh, I should mention that some people call defining a model initialization, and some people call training the model processing the model. Those are different names. By the way, almost everything in statistics, machine learning, and data mining has a similar but slightly different name, of which only the statistical name is correct and the other ones are slightly wrong. That's my perspective, okay? All right. I am not going to discuss every algorithm available, because that's what you can learn by watching my videos, by watching my yesterday's seminar, by attending the 4-day intensive hands-on course in Stockholm. But I want you to understand that almost all machine learning algorithms can be roughly grouped into these 4 super categories: classifiers, clustering, regression, and recommenders. Classifiers are by far one of the most important. Almost everything we do is a classification. Fraud, not fraud. Will buy 4 cars from me or more or not? Does like the purple widget or not? But sometimes you don't want to classify things. Sometimes you just want to see, how do the points group? Where are the natural boundaries? That's clustering. Clustering divides your data into naturally occurring separate groupings. Imagine, in 3 dimensions of age, gender, and a relationship to the head of household, young people, old people, females, males, sons, daughters, parents. If you plot every data point, how many clusters do you see in your mind's eyes? 3 or 4? You should see a sphere of younger male sons, a sphere of younger male daughters, and a stretched elliptical, like a cigar shape, of older parents of both genders. That's clustering. We found 3 clusters. Why is it useful? Because if somebody enters a data point over here, what's that? Young male daughter who is a parent, you can see straight away this data point doesn't belong to any cluster. You detected an anomaly, potentially fraud. Clustering is a very interesting technique for doing a lot of stuff. Regressions, especially traditional, simple, statistical, numerical regressions, will create a beautiful, simple mathematical formula that predicts a numerical outcome based on numerical and categorical or discrete outcomes. And am I right in thinking that, Peter, will you have a session on that during the conference? Nope, nope. Okay, I think he does. Recommenders is the thing that everybody loves to talk about. Recommending the best product to buy. Recommending the product the customer doesn't know about, but they should be interested in. All of that class is one of the probably freshest and richest areas in research right now. There are model-based recommenders, there are model-less recommenders, there are filtering-based recommenders. It's a huge, huge area. And if you are into recommenders, I can guarantee that as long as you do it well, you will have a good job for at least another decade. It's probably one of the more profitable and one of the better parts of data science to get into right now. Now, in my deck, I have hidden slides. So you see, it's not magic. Slide, next slide. Slide, next slide. But now I'm going to press the magic button. If you use PowerPoint, the button is H. And using that, you can see a few hidden slides. Where are the hidden slides? No, the magic button didn't work. Yeah, because I was in presenter mode. There you go. Algorithms in SQL Server Analysis Services. Some useful R algorithms, Azure machine learning algorithms, and Mahout and Hadoop algorithms. Have a look. Thank you. Thank you. I need to go on a PowerPoint course. After using like for 25 years, you can always right. Algorithms in SQL Server Analysis Services, you understood them. Algorithms in R, random forest boosting, pretty good stuff. Algorithms in Azure ML, Microsoft introduces decision jungles, lots of other pre-existing stuff and a few other cool ideas. And finally, Mahout Hadoop, recommenders using collaborative filtering. The reason I use it, everything else I don't use it for, done. Or come on a 4-day course. Or I've got about 11 hours talking about it on the website, but I don't have this time here. I have to pretty much squeeze the 2 demos and a few words into the remaining 33 minutes of my presentation. So let me show you now a gentle introduction to machine learning using very old but very good technology of SQL Server Analysis Services data mining, which I use on every customer project, and you're gonna have to rip it out of my cold hands before I stop using it because it's so good. Yes, I'm gonna talk about Azure ML too, and I will talk more about Azure ML than this thing, but I'm gonna talk about this one because I'm on stage and I decide what I want to talk about anyway. So there you go. It's so good, it would be a sin not to talk about it. First of all, the easiest way to use this technology is to actually not know what you are doing at all, get some data like this, my potential future customers, and as soon as you've got this data, using the Analyze tab and its Highlight Exceptions button, I hear you say, I don't have this button in my Excel. Right, that's because you haven't installed the free Microsoft data mining add-ins for Excel 2013. Oh, but you don't use that. You use Excel 2000. Oh, fine, install it for Excel 2010 or Excel 2007 or even the older one. It doesn't work, but you can install it. Highlight Exceptions button is like magic. It takes the data, sends it to my locally resident SQL Server Analysis Services server. Oh, it's working. Found the clusters and now asks every question. Are you in a cluster? Are you in a cluster? Are you in a cluster? And it says that with a threshold of 75%, 137 data rows are not in a cluster. I have 32 exceptions regarding the birth date, but no exceptions looking at marital status or gender. And if I wanted to, I could just scroll through this data to show you some of those exceptions. Let me find just one exception. Where is Jacqueline? Oh, she's hiding somewhere. There you go. Jacqueline Murphy is an exception. Why? Brighter yellow tells you why. Because she was born in 1901, which just doesn't happen to be, similar to the age of other people in this data set. Of course, now everybody says, I don't need data mining for that. Min, max, whatever, sorting, box plot, visualization. You're right. You don't need data mining for that. It just proves it works. If you want to understand, however, the other exceptions that I've got over here, let me just find an example of a good one. That's a good one over here. Jessica Walker is a single lady with a good income. She has no children, partial college education. She's a professional, and she's got 2 cars. Well, in this data set, unfortunately, being sexist or not, statistics says that she probably should only own 1 car. 2 cars is unusual. And now you are thinking, do I have a rule encoded here which says, if this and that, then that? No, I don't. This is clustering. It detected these points in space, and she's just a little bit too far from the nearest cluster. She is not representing regularity in this sense of what happens in the data set. And that was just one little button, this one here, and I don't even have time to show you all of those remaining buttons, but what I will show you is how easy it is for you to build a model using which you can predict how many cars people will buy from you. I could do it in Excel, but I will not, because it's easier for me to do it using SQL Server data tools. However, it's easier to consume the built model in Excel than using this tool. And what I will do is I will quickly connect to my existing project that has all of the necessary data sources and data source views configured. It even has some data mining models, all of which are available, including the data set from my company's website. It's called Happy Cars. If you want to do this, this is one of the better data sets for learning data mining. And there is Happy Cars Azure, which will help you learn, of course, Azure ML. Right, so what am I going to do? I'm going to right-click, new mining structure, next, from my database, using which algorithm? Please give me a decision tree as opposed to everything else. And where is the data? In number of purchases, customers table, absolutely, these are the data points. What would you like me to predict? I would like you to predict for me how many purchases customers will make. And what would you like me to use to make this prediction? Everything except, don't look at people's names because they shouldn't correlate. Sometimes they do, but they shouldn't correlate. Don't look at the profit generated because it's obvious that profit will be directly related. Or if you don't know what to click the suggest button and it will look at the data and it will tell you don't look at profit because it doesn't make sense. So, there's actually help behind the scenes. But we're going to go with that. Say next. I will quickly change one thing over here, which is explained in about 20 minutes in a suitable section on the video. I will keep 30% of data for testing, and I will call it my customers pass, and this I will call customers pass decision tree. I will allow the drill through, I will hit finish, and I will process the whole shebang. So what happens now is SSAS goes off, sucks the data, looks for patterns using decision trees, and it munches and does a little bit of magic. And eventually, when deployment has been completed on my server, it shows you a decision tree. Do not look at the decision tree first. First, check if it makes sense. You want to validate it before you look at it. It is so difficult not to look at it. Most of my customers want to see it before they know if it's valid, and sometimes it puts a spell on them. It puts a spell on them, and they don't care if the model is valid because it looks good. And most of the time, they make business decisions based on that, and goodness gracious, those business decisions sometimes are good, but they shouldn't be doing that. What you should do is look at the mining accuracy chart and see, for example, if it can correctly predict people who buy 4 cars. You click the lift chart. Microsoft never figured out how to do proportional plots, so you kind of have to resize it. And you look at this and say, wow, that's good, that's good. If your models look like that, they are good. Do you know why? Well, I don't have time to explain it, but I have about 1 hour session that explains that in detail on the website. But it's very easy to explain. This bad, this magic. The closer you get to here, the better it is. The further you are from here, the better it is. Magic would be cool. We can't get magic. Actually, you will get magic. When you get magical results, it means you messed up the data. You have to go back and figure out, why is your model too clever? You don't want it to be too clever. If it's too clever, something's wrong. You need it a little bit dumb. We have a name for it. That little bit of dumbness is called generalization capacity. You want your model not to remember every case. It's called overtraining, overfitting. Be slightly more aloof. Yeah, I can tell you generally, but I'm not going to tell you exactly. That's good. I know why. It should be accurate, but we don't want it accurate. We want it to be more or less that. This is good. This is good. If you get it like that, that's pretty cool. Now we can look at the tree. You paid the price of validation. You go to the mining model viewer, and using the mining model viewer, you need to see, of course, the legend, which is over here. And the legend has colors. And those colors represent the numbers of cars people buy. And I love purple people. Can you see it's a histogram? Blue people, most frequent case, buy 2 cars. But I like purple people. They buy 4 cars. So how do I find purple people? Well, first of all, you can already see that most of my purple people are here. This is people who have an awful lot of money. And if you look at the dependency network, it tells you that, in fact, the most important variable that influences the number of purchases is income. The next most important variable is number of children. They've got commute distance, education, and all the remaining ones. But the question I want to answer is, amongst people who have big income, what is the next variable that matters the most? If you paid attention over here, you should tell me total number of children they have. But that would be a wrong answer, because this is a generalized answer for everybody. Whilst we are no longer looking in the tree at everybody, we are now looking at a partition of people, only those who have big income. And amongst those, as you can clearly see here, I want people who do not have a graduate degree. Those people are far more likely to buy 4 cars, whilst people with too much education don't buy as many cars from me. Don't know why, but that's not quite real. We cooked the data a bit, all right? You should laugh. This is a data mining joke. When you spot an aberration in the data, and you say, of course, okay? Anyway, doesn't matter. This one works well. People who have this level of income, age matters. This one works well. People with this income, how many children they have is what matters. Okay, so let's say they're between 25 and 50K of income, and you have like more than 4 children. What's the next thing that makes you buy more cars? Well, let's have a look. The next thing that makes you buy more cars is knowing how many of those children are at home. Because if you have 4 or more children, and 3 or more of those kids are home, you are green. That means you are buying 3 cars. If you have fewer than 3 kids at home, you are blue, and that means you are only buying 2 cars. And I could show you all of the 7 levels of that, and you probably need to understand it to this level if you wanted to, but you don't need to, of course, do it with me right now. You would spend a little bit of time analyzing it. The cool thing is that we could take all of that magic that we tested and apply it to predict now over here how many cars those future customers of mine will buy using the data mining query button, making sure I'm connected to my SSAS server, and using the customer's past DT model that I have just built, using the data in this Excel table, connecting the correct inputs to each other, I could predict the predicted purchases. I select the predict function, number of purchases, click OK, click next, click finish. 4,000 predictions later, over here, my model predicts how many people will buy this number of cars. Well, this was all nice, but this is old 10-year-old technology. So why am I showing it to you? Have you shown it like for 10 years? Why am I showing it to you? Because that decision tree was visual, because it was cool and easy and nice to see it. Of course, you don't have to use this technology. You could use the newfangled tool called RStudio. Well, actually, R is the tool. RStudio is the interface to that tool. And by all means, you could also build very cool-looking decision trees. I'm going to show you how cool those decision trees are. Let me just make it a little bit easier. I should have preloaded a different data set. Well, doesn't matter. I'll build a decision tree for you. Wow, how beautiful. Can you see it's a tree? It has a root, and then it has 2 branches, each with 2 nodes. Right. Not very beautiful, but it can do a lot of things that we couldn't do in SSAS. Forests, boosting, support vector machines, neural networks, and that just using buttons. And if I were not to use the buttons, but actually write all of the code behind, I could do even more. But all of this stuff, as much as it is highly visual, is somewhat limited. It's an old technology. It's a technology that is beautiful for visualizations, but if you want to get more power out of these algorithms, or if you want to deploy these algorithms using modernity of web services, nobody is going to help you more with that today on the market than Azure Machine Learning. It's a machine learning platform in the Microsoft Azure cloud, which is why it's called Azure Machine Learning. For change, Microsoft has a name that actually means what it is. Anyway. Azure Machine Learning comes with a few tools inside. The main tool is actually called ML Studio, or simply Studio, and to get to it, you have to first walk through the Azure portal. This is the same Azure portal, that's your doorway to all things Azure. That's where you start, that's where you provision your ML workspace. That's where you would also configure your lovely SQL Azure databases from which you would get the data. No, you don't have to, you can get the data from text files, but please don't do that, put it in a normal database or it will suck later. And you launch ML Studio, connecting to your data, building your experiments, validating them, publishing them as a web service, and then you go back to the Azure portal to throttle them up and down and to monetize them. Because if it works, you can sell your service through the Azure data market. That's not fully automatic. You push a button, somebody in Redmond looks at it and checks whether it kind of follows Microsoft's unpublished policy of what you should and shouldn't be doing. And if it does, which is unpredictable, even if you have a predictive analytical model, you will start making money because they will be selling this service to do something amazing using your intelligence without exposing your intelligence. Cool idea, try it out. All right, so how do you do it? It's an iteration of iterations. The high-level iteration is to do something with the data, to model and validate until your model is valid. And if it's valid, you push it out through the web service. However, you won't get there straight away. So first, to get the data, you will connect, transform it optionally. Yes, you can do a lot of transformation in Azure ML, but that's not the best place to do the transformation. What's the best place to do transformation? In SQL. You guys are the best people on the planet to give me good data. I do not want to be using Python or R or whatnot, or Azure ML, or this or that to restructure the data, even if I can, because the best place to reformulate, to beautify and cleanse the data is using what you know best, SQL. Operational data stores, views, or whatever, or amazingly beautiful queries that look like poetry that you will be seeing in the next presentation are all appropriate ways to get the data to the point that you can initialize and train the model with them. Score, which means predicting. Predicting what? Predicting test results, because whenever you build a model, you will split the data into two bunches, for training and for testing purposes. You build a model, and then how do you test it? There are many ways to test it, which I explain in a module on the website, but one of the important tests is that you predict known outcomes. Why would you predict known outcomes? Because after you predict known outcomes using your model, you can compare what was predicted to what you knew was the case. Does Azure ML cheat and look at the known outcomes and say, I'm going to copy? No, it doesn't. It's actually relatively okay, so it doesn't. It lets you compare the two using visualizations known as receiver operating characteristic curves, lift charts, plot charts, or calculating numbers like precision and recall, all of which are far easier than it sounds, and I hope you will download my slides to have a look at that. But if everything's fine, it's still not ready until the business person says this is useful. Because very often, for example, for my retail customers, one of the early models we'll build will create very accurate, very valid, well, not necessarily valid, very accurate and very reliable models which say, for instance, that feminine hygiene products are usually purchased by females. Accurate, reliable, not very useful. Yep, in my job, I suffer between 8 to sometimes 9 out of 10 models which are like that. That doesn't mean that I won't find the 1 in 10 that is valuable, but I have to go through quite a bit of validation. And if you don't know the domain of your customer, without knowing that domain, you may set yourself for a small problem. Because the customer will look at it, look at you and say, this guy or girl doesn't really know what they're doing. So be careful how you evaluate validity of a model. Okay, enough talk. Let's have a look at the doing of this part, which is pretty much the last part, because look, click, next stuff will be the summary, and then there will be want to learn more. But before we get to that point, I would like to show you how to do this in Azure ML. So let me switch back over here. And I could do the full thing, everything I need to do, but I'll do a partial thing as much as I am able to do in the limited time of a 1-hour presentation. I will start by showing you that you could get the data into Azure ML from any of these files. Don't do that. Why not? The data types will not be quite right. The strings will look like numbers. Numbers will look like strings. The commas will be in the wrong places, and you'll be like, oh, spending your days cleansing it. So just do the right thing. What's the right thing? Well, the right thing, as you probably have already guessed, is to stick it in some... don't send me email to this address. I don't read it. It's you know, just a login and thing. What's the right thing to do? What's the right thing to do is to stick it in a SQL Azure database of some sort. It could be in a VM. It could be in whatever database you want to have it. My compromise between simplicity and ability to work with it is to stick it in SQL Azure. Cheap, cheerful, not the fastest, but it's okay. And as long as you put those SQL Azures in the same region where your machine learning workspaces have been provisioned, you will not pay for data transfer, as well as it will be relatively fast. So, okay, so you've got the data in the right place. You are not going to use a text file. So what you're going to do now is you're going to create a new experiment, a blank experiment. And over here on the left, there's a ton of stuff you can do in Azure ML. And one of the first things you will do in Azure ML is you are going to read the data. And you will use this reader to connect to your SQL Azure database, which hopefully I have. There you go. The database name is Happy Cars Azure. The username is Rafal. Oh, which password? Okay, guys, it's one of two. So shorter or longer? Maybe shorter. No. In some browsers, you can't delete. They'll fix it. Hopefully, select the insecure option, and now I'm going to write a query. Select. All right. Brent isn't very impressed. Run. Why do I run? I run to check if I got the password right. That's the first reason. And the other reason is that once you run an experiment like that, it will get the schema of the data in, which means that I will not have to type in column names from now on. I will be able to pre-select them from the list. Oh, look at that. Rafal got the password right. Finished running. Check. I know something about it, I guess. Right. Let's have a look at the data. Right-click and visualize. This is what came from the SQL Azure database. Hey, does it look a little bit like the data you saw earlier in Excel? Absolutely. It's exactly the same stuff. I've got all of the parameters, including profit generated, and I also have engineered a feature. What's a feature? Feature is the machine learning term for inputs. A column which is used as input in machine learning is called a feature. All right? That's it. And we like a lot of those features. How many? A lot. How many? Thousands. Tens of thousands. Like a perfect data structure for me is a flat row of data with tens of thousands of columns. Where would I get tens of thousands of columns, you may think? Well, very easy. You start with age, gender. Okay, that's going to be like 3. And then, how many purple widgets did they buy? How many pink widgets they bought? If I want to model number of widgets. But what if I want to know if this person buys more than 4 widgets? No. Number of widgets is not good for that. I want a flag. Bought 4 or more purple widgets. What if I'm interested in knowing whether this person bought 3 black and 5 purple widgets? I'll have a flag. Bought 4 purple and 3 black widgets. Or was it the other way around? And then I will add relationships. The mother of this person was buying a purple widget. And then I will add aggregates, and then flags of the aggregates and relation. That's called feature engineering, and it's a bit of magic, okay? How many features to create? Which ones to delete? Experience will tell you that. But until you get there, I have created a feature called purchased 4 cars or more, which I will be modeling right now. How? What I will do is, first of all, I will zoom out of this. What I will do now is I will select some columns from this using the various data transformation tools. I want to project my columns. Project means here as a verb, select, launch column selector, and we are going to include the birth date, marital status, income, gender, total children, number of children at home, education, occupation, home ownership status, commute distance, and I'm almost there. Number of purchases is what we want to predict. Therefore, you have to, oh no, we are not going to be. We are going to be actually predicting whether this person purchased 4 or more cars. Okay, so I have selected my columns. I say good. And now it's time to actually do some modeling. What I want to do is I want to build one of the classifiers, because I want to classify my people into those who will and who will not buy 4 or more cars. So it's time to use one of the machine learning initiatives initialize model module. Specifically, it will be a classification module. Do I want a multi-class or a two-class classifier? Well, that depends how many outcomes there are. Will buy 4 OMO cars. True, false. How many outcomes? 2. Therefore, I need a two-class classifier. Very easy. If I was predicting multiple outcomes, I would use a multi-class classifier. So, using a two-class classifier, I have a pretty cool choice of many different options, of which I'm going to use a two-class boosted decision tree. Why? Well, because it's the most similar thing to the decision tree that I have shown you earlier in SQL Server Analysis Services. So, I've got one, and now it's time to train it. So using the train module called train model, I will take my two-class boosted decision tree and my filtered data, and I will have a trained model. That says, oh, you have to tell me what you are looking for. So over here, I will launch the column selector, and I will tell it that purchased 4 OMO cars is the outcome I was interested in. And I'm almost done, except before I do anything, we have to do what? Yes, validate. We have to validate the outcome. So, to validate the outcome, well, in SSAS, it was like press one button, ta-da, a chart appears. In Azure ML, you have to know a little bit what you're doing, but it's not very difficult. I need to use the trained model to score a test data set. I don't have a test data set, no problem. I will delete this link, and I will make a test data set by using one of the data transformation sample and split tasks, which will take my incoming data, and I will configure it to send me 70% of data to the left and the remainder to the right, optionally stratified if you are studying unusual or rare outcomes. Now that I've got my training data set, I can use this training data set, the 70% of the data to build the model, and this testing data set I will use to score the model, in other words, perform predictions. So using the score module, which is called score model, I will take the just trained model and the testing data set to create predictions. And now I simply have to evaluate if these predictions are any good. So using evaluate model task, I will connect those two together. This one I could use to optionally connect another model to compare which one is better, but we are not going to do that today. So we have pretty much built our first and entirely, hopefully complete and with a little bit of luck, functioning Azure machine learning experiment. I should have changed the name of it. I forgot to rename it, but we'll do that in a moment. It's been queued, and it is now being at the mercy of the Azure environment somewhere in South Central United States, where it is processing as much in parallel as possible in the paid version, and not so much in parallel in the free version, all of the modules and the data flows that I have configured. It split the data. It is now training the model, and hopefully in about 1 minute, the model will have been found, and we will be scoring it right now. And whilst it's evaluating it, I could have already right-clicked over here and visualized the model, except, oh, Azure ML doesn't visualize models at all. Hello, Microsoft, give us some visualizers, pretty please. In the meantime, that's why I use SQL Server Analysis Services data mining, because it has the coolest visualizers on the market. Those are so beautiful, you'd be silly not to use them. But in our case, we can't visualize them, so we're just gonna live with the fact that hopefully there is a model, but you know what? It's not a biggie, because before you see the model, you need to check its validity anyway, you remember? So actually, we shouldn't have looked over there. We should have gone straight here to see whether the model evaluates. Wow, that's even better than the one I had earlier. How about the precision recall? Wow, pretty good. A lift chart, ooh, cool. If you get results as good as that, send me an email, I'll be hiring you at some point. In addition to that, you can also play with something that's very important that I don't have time to explain, but I explain in the videos and also in the seminar, of course, which is how to choose the right threshold of predictive probability to correctly balance the number of false positives with false negatives. Because one side will have no false negatives, but also everything will be a false positive. The other side will give you so many false negatives that nobody will want want to do business with you. And the cost of false negative and false positive is different in different businesses. So choosing the correct threshold and optimizing your model for it is important. But let's say you've made a decision, everything's fine, you are ready to deploy it into production. The easiest way to deploy it to production is to click on this button, Create Scoring Experiment, and it's very, very sexy what it does. What we'll do is a little bit of a song and dance. I don't know how much money they spent on that, but I would rather they implemented the visualizers, but that's okay, at least we got something. And at this point, you might want to use it. Wrong. It does it incorrectly. Thank you very much, Microsoft. What you need to do, as soon as you have used it, you have to detach that thing from here. You have to switch yourself to this view, and you need to reconnect the web service input to the score model task. Additionally, you should also change the parameters which your model will be accepting, since now for scoring purposes, you do not actually want to be asking for the data that you are trying to predict. But to save you time with all of that, rather than redo it, especially as I've got only 4 minutes left in this presentation, here is one I have prepared for you earlier, and I have even enhanced it, so it's a little bit better than the one that I'm showing you over there. Web input still goes to the same place. I've got my reader, I project the same columns, I score the model, perform prediction, and then I apply an operation comparing whether the prediction is greater than the threshold of 0.3. Why 0.3? Because in my business, that's the right balance between the cost of a false positive and a false negative. Shouldn't that be always 50%? Have you been to the airport recently? Have you gone through a metal detector? Is it set at 50%? It was set at 50%, then half of all the people going through it would be terrorists. That's not quite the case. It's actually set at some extremely small number. So it's not normal to assume that you always end up setting that value at 50%. In fact, this is one of the bits of magic in business decision making to choose the threshold correctly. But once you've done it, I take that calculation and the predicted probability, join them together, give them some friendly, cuddly names that the user will like I'm going to call it will buy 4 or more cars and so on, and I've got my web service. Press this button to publish the web service, and what you get at that point is a web service called buys many cars, and using the API help page, you will get both the URL where you can invoke it, you will also get the code that you can copy and paste in C#, in Python, or in R. In C#, if you want to do it, many lines of code. If you want to do it in Python, not many lines of code, and fewer brackets. I like Python a little bit more, I think, now. You could also download an Excel workbook that will let you do it, but it doesn't work on 64-bit edition of Excel. Not yet, so I'm not going to show you that. You can also hit the test button, enter some data, and run the prediction there and then, but of course, I have written a little bit of code to show you how you would deploy this into a production application. So let me show you the code that I have written for your pleasure a little bit earlier by copy and pasting and slightly massaging a little bit of that Python code. And what you've got is a little bit of JSON with the data points that we've been playing with, trying to predict whether whether a female with 2 kids, bachelor's management, who has a home 2.5 miles to travel, would buy 4 cars or more. So I construct my URL endpoint just like it was in the help file, provide my super secret API key, package the data, call that URL, synchronously wait for the results which I read from the web invocation, and I print the results for you. So when I started, that call actually went into the Azure cloud, and this particular lady will buy 4 cars or more from me with a probability of 0.37. In other words, 37.5% probability. So as you see in this example, actually deploying and operationalizing your intelligence is pretty easy with Azure ML. And you could do it by plugging into it also code written in R, code written in Python, pretty much invocation to anything on this planet, as long as you can call it using OData. Not a very fast thing, but definitely a supported way of consuming information information for predictive purposes. In summary, in this presentation, you have learned that machine learning experiments lead to building data-based models. Algorithms find patterns. Those models can be easily deployed. And with a little bit of luck, valid models in deployment used by your applications will help you change your business, for example, by reducing the amount of fraud that your company may be struggling with right now. To learn more, in addition to project.cherry.com and my 4-day First in Europe course in depth on this subject, I also want to remind you of the special offer available only during this week. That coupon will remain on the screen until Brent removes it. So, well, I hope you're gonna want to do a little bit of machine learning. I hope it will help you get into that exciting field of data science. But if you don't, and if you stick doing SQL and queries, that's great, because we need you forever and ever to keep beautifying the data that we can be analyzing later too. Thank you very much for your attention.